Let us find out, calculate V dV by dt d square v by dt square at t is equal to 0 plus. I already told, for series circuit they will ask calculate I dI by dt d square I by dt square for series circuit. If they ask parallel circuit, this is a parallel circuit. For this type of parallel circuit they are going to ask V dV by dt d square y by dt square. For series circuit you have to apply KVL. For parallel circuit you have to apply KCL, Kirchhoff current law. So in the given network, the switch is closed, the switch is opened. So in the series circuit, they will give the switch is closed. The switch is closed at t is equal to 0. But here for this parallel type of circuit, they will ask the switch is opened. That means initially the switch is closed. You see the arrow mark. Arrow mark is away. You see the diagram here. Here it is initially open. Finally, arrow mark said it is closed. Here initially it is open. Here initially it is closed. At t is equal to 0, the switch is open. So this is the difference between series and parallel. In the parallel circuit, they will give the switch is open. Initially it was closed. At t is equal to 0, it is opened. So now let us do this. So this is a very, very important concept we should remember. Please see here. You have to find V dV by dt d square. Where is V? In the series circuit, they will write circuit current I. This one. They will give circuit current I. This one. In parallel circuit, here they are given voltage V of t, nodal voltage V of t there, mesh current I of t here, nodal voltage V. This entire circuit is one common node here. This full circuit, you can see this full is single node, which is voltage is V of. You have to find V of t at 0 plus, dV by dt at 0 plus, d square V by dt at 0 plus. It's an important problem. Let us solve this now. Initially the switch is closed. Initially the switch is closed. For t is equal to 0 minus, for t is equal to 0 minus, the switch is closed. Please see here, switch is closed. This is short circuit, that means closed. And V of t, since it is short circuit, since it is the switch is closed, no, all the current 1 amp current is full current will coming in this path only. No current will flow through this. No current will flow through inductor. No current will, because in your room, if any short circuit, all the current will go through short circuit path. So initially the circuit is closed at t is equal to 0 plus only. Okay. This is time t is equal to 0 plus. At t is equal to 0, the switch is open. Before that, the switch is closed. So before switching, okay, all the current 1 amps, the full it is flowing through short circuit path, and no current will flowing through resistor, no current is flowing through inductor. So initial current in the inductor is 0, IL of 0 minus is 0. Okay, IL of 0 minus is 0. You can see the equation, it is 0. This is the I'm talking about this period, this time. For t is equal to 0 minus, the switch is closed. This 1 amp fully flowing through this, and no current is flowing through this. So initial current in this one is 0. And voltage, if I measure there, V of 0 plus, it is short circuit, no? So V of 0 minus is also 0. V of 0 minus is also 0. V of 0 minus is also 0 because it is short circuit. Now at t is equal to 0 plus, the switch is opened. At t is equal to 0 plus, at t is equal to 0, the switch is opened. At t is equal to 0, the switch is opened. The switch is open. Now at t is equal to 0, how the circuit behaves, you should remember this. Okay, at t is equal to 0, at t is equal to 0, inductor acts as open, inductor acts as open, capacitor acts as short circuit. So in our circuit only inductor is there, so inductor acts as open. Inductor acts as open. Just after switching, inductor acts open. The switch is open. Here actually switch is there. The switch is open. This is switch is open. This is inductor is open. Here the switch is open, and here inductor is acts as open. Okay. Now before switching, the switch is closed and all the current is flowing through short circuit path. Now this 1 amp will not go through this path because this is also open. Now all the current 1 amp, this 1 amp will go full through this 1 amp. The full 1 amp will go through this because this is also open, this is also open. That is infinite resistance, infinite resistance. This 1 amp fully goes through this. So now what happens? Since inductor acts as open circuit, just after switching, current IL of 0 plus is 0. We have to find V of 0 plus. So here V of 0 plus, here all the current flows through, short circuit path, and 1 amp into short circuit means 0 resistance. It is 0 volts. V of 0 minus is 0 plus, and even if you consider this voltage across resistor, all the current flows through this. So current through resistance is 0 amps. So R into 0 is, we'll get 0 volts only. But now the voltage V of t is drop across 100 ohms. So 100 into V is equal to what? V is equal to what? R into I. Okay. 1000 into 100 is the resistance value. It is 1 amp. So it is R into I. V is equal to R into I. R is 100. I is equal to 1 amp. So 10 into 100 into 1 is 100 volts. So it is 100 volt. It is V of 0 plus. Just after switching, V of 0 plus is equal to 100 volts. Understood? Just after switching, V of 0 plus is 100 volts. Now let us find out dV by dt. You have to find out. So for that, you have to write, considers for t greater than 0, you have to write KCL. For t greater than 0, you have to apply KCL, Kirchhoff current law. So Kirchhoff current law, you have to remember that equations. This is a current equation. For parallel circuit, you have to remember this equation. For a series circuit, you have to remember this. For parallel circuit, I is equal to, in resistance, it is voltage by resistance. In this problem, L is given, no? So current in inductor is given by 1 by L integral of V of t dt. Suppose capacitor is given C into dV by dt. So in this problem, you have to remember this 1 by L integral of V of t dt. So it is, if you apply KCL, this 1 amp is going through this and this. This 1 amp is current going to the node is equal to current leaving from the node. So, or you can write all the currents going towards the node minus 1 is equal to current leaving from the node. All the currents are assuming that current leaving from the node. You can write minus 1 is equal to current through this and current through this, or you can write current going through the node is equal to current leaving from the node. So current going to the node is 1 amp, current leaving from the node is this. So this you can consider a reference. So what is the expression? 1 by L integral of V of t dt, and what is the current in this one is V of t, this is zero, potential difference. Okay, I'll write here one more equation here, you can, if you want. Okay, I'll write here current going to the node is 1 amp, current leaving from the 1 is equal to, this 1 is equal to current leaving from the node is 1 by L integral V of t dt plus, okay, plus current in resistor is equal to V of t minus 0 by 100. So V of t by resistance. So 1 is the current, right side I am writing. 1 by L value is 1 Henry. Integral of this also you have to write V of t. Okay, better you write V of t here, and here also V of is equal to 1. Now I want actually dv by dt. So here you can see v of t is there, integral is there. There is no dv by dt. So you have to differentiate. You have to differentiate this equation. So if you differentiate, you are going to get, okay, v of t is a voltage with respect to time. Now it is 1 by 100 dv by dt of dv by dt, and integral and differential will get cancelled. You'll get v of t is equal to 0. And after that, substitute t is equal to 0 plus. Substitute t is equal to 0 plus. dv by v of 0 plus is how much? V of 0 plus, you have to get it from previous. V of 0 plus is 100 volts. V of 0 plus is 100 volts. So you are going to get t is equal to 0 plus 1 by 100 dv by dt of 0 plus. And if you bring it to right side, uh, this is minus v of t minus v of t, and if you cross multiply, this 100 will come to here. If it is numerator, it will come to denominator here. Here it is in the already in the denominator. If you cross multiply, this will go to here. This minus this 100, no, this 100 will come to here. It came here. Minus this 100 v of 0 plus. Now substitute v of 0 plus. V of 0 plus is 100. This 100. V of 0 plus is 100. So 100 into 100 is 10 power 4. So minus 10 power 4 or 10,000 volts per second. In the di by dt, it is ampere per second. It is voltage per second. So this is your dv by dt. Next we have to find out d square v by dt square. So you have to differentiate this equation once again. This equation you have to differentiate once again. Sorry, not this one. First time you are differentiating this, no? This equation. 1 by 100 d square v by dt square. And again you can write here. General time you write here. E t d square vt by dt square plus dv naught dvt by dt equal to 0. So you have to find out d square v by dt square. So substitute this 1 by 100 d square v by dt square is equal to minus dv by dt 0 plus. If you substitute to dv by dt value is 1000, 10,000. And d square v by dt square is this 100 you have to pass multiply. For this you have to multiply with 100 once again. Okay. 10 power 4 with 100. So minus into minus becomes plus. 10 power 2, 10 power 4 is 10 power 6. So 10 power 6 volts per second square. This is an important problem. Please don't get confused. This is also important. The parallel circuit. I will repeat once again. In a parallel circuit, okay, they will ask the switch is opened at t is equal to 0. In the series circuit, they will ask the switch is closed at t is equal to 0. In the parallel circuit, they will give the switch is opened at t. Before that, the switch is closed. So once the switch is closed, entire current is flowing through short circuit path. No current is flowing in this. So initial current in the inductor is 0. Initial current in the resistance is also 0 because all the current flows through this. So V of t is equal to 0 because short circuit is 0 resistance and 0 current in the home. For t greater than 0, inductor acts as open circuit, switch is open, inductor also open, all the current flows through resistance. Since current is flowing through resistance, voltage V of, if you measure voltage, ping multimeter positive and negative here, it is drop across this 100 ohms, 100 into 1 amps is 100 volts. For t greater than 0, apply KCL, Kirchhoff current law. It states that algebraic sum of current entering the node is 0. Current entering the node is current leaving from the node. Current going to the node is I 1 amp. Current, two currents are leaving. Current through inductor, current through resistance. Substitute, differentiate one time and substitute the for t is equal to 0 plus substitute and find out. Once again differentiate. Again substitute the value of dv by dt. You will get d²v by dt², and the unit is volts per second, and it is volts per second square. It is d²v, v only, not v square. d²v by dt square. T square means second square. Thank you. And you can also think here also same problem is solved. Okay. Current in the inductor is equal to initial current in the inductor is 0. Same problem. Okay. You have to write KCL. Current 1 amp is equal to current through inductor, current through resistance. Differentiate. You get V of t by L, and then 1 by 100 dV by dt. At t is equal to 0 plus, you will get 100 V of t by L value is 1. So 10 power minus 4, not 10 power 4. Differentiate once again with respect to t. You will get minus 100 dV by dt. Substitute the value of dV by dt at 0 plus. So minus 100 into minus 10 power 4. It is going to minus into minus is plus 10 power 6 volts per second square. It's a very easy problem, and repeatedly asked problem. So you can mark it as important. So revise 2-3 times this problem. Thank you.